GameBuilder Studio.
Okay, I'd like to cover scene tracking in GameBuilder Studio, but before I can do that, I need to give you an understanding of how the scene is laid out. What is the structure of a scene in GameBuilder Studio? So if you look at the layers panel, this will make a lot more sense of why this is laid out this way. In the layers panel, we have the root layer, which is a scene object. And this is just like a group or container that holds everything in that scene. So right under that, in the display hierarchy, you have a scene layer, which manages sorting the objects depending on what order they should be displayed. So you're also allowed to have multiple scene layers under a scene object or a scene container, and you can parent objects into those different scene layers, and you have control over hiding and locking those as well. Now, when you want to track an object, the actual root scene container is the object that manages following the object and moving the scene according to where that object is. So for every scene container, you can track an object within that scene container. Now you'll notice in some of the tutorials and some of the templates, the way that we're able to achieve a UI layer over top of a scene with moving objects that has tracking going on is by adding an additional scene container that doesn't have tracking, and it'll make sure that the objects in that scene stay put. So whatever is moving behind that can move freely, and the scene that's on top just stays put. So that's how that's achieved. So just to show you quickly, it's fairly easy to add tracking. You just simply add a rule component, drop in a track entity action, and you have to find the entity and then select what renderer on that entity you want the scene to track. And this track offset property is what controls how the scene is tracking. So if I launch this, you can see here, if I drag this, the scene is going in the opposite direction. So if I drag left, the scene is moving to the right. If I drag right, the scene is moving to the left. So that's the offset. It's going in the opposite direction of the object's movement. Now, let me add an additional scene container in here, add a scene layer to that. And let me create another object that I'm going to use to simulate a UI element. I'm going to remove its collision spatial because I don't want it to simulate with the scene. And I'm going to drop it on this new scene layer. Now this is outside of the scene being tracked. Now if I run that, you'll see as I'm moving this object, the object at the top is not moving at all. It's just staying pinned into the top right corner of the scene. So that's how we simulate a UI element using multiple scenes and tracking one of those, using tracking in one of the scenes. One of the things to keep in mind is when you're using collision shapes, colliding objects on different scene or in different scene containers, the physics engine doesn't respect the scene layering, so it doesn't know the difference between objects in different scene layers. So if you have a colliding or collision shape on this object, this ball would collide with that regardless of if it's on a different scene container. So it's important to keep in mind. Now, besides tracking by offset, you can track the actual exact position of the object. So if I go to the track entity, I can uncheck track by offset, and the scene should track this object's exact position. Now, if I move this guy to the right, the scene is moving with it. It's moving the scene in the same exact direction. Now, you normally don't do this with physics bodies and physics objects and interact with a mouse constraint like this while tracking it, because there's a little bit of a conflict. The scene is moving the objects as well as the mouse is moving the object. So you normally don't do this, but this would be used for a scenario where you have a menu object or you have some element in the scene, uh, in your game scene, that you want to move in its entirety. So maybe you wanted to move an entire scene's contents from left to right. Um, a good example of this would be one of the projects that we're working on right now is a mobile game, and we're using this technique to simulate the transition of screens. So if I launch this, once the user signs in, this screen or this scene container is going to shift all the way and animate to the left, and it'll look like a little transition. Now, that's just a scene container that has a camera or an object that's acting like a camera and is being tracked. And as I animate the object to off-screen left, the entire contents of the scene shifts with it, and it transitions off the screen. So that's one way to utilize tracking with the track by offset property unchecked. Another good example of this is the level select menu example project that ships with GameBuilder Studio. It is a menu system here that has two screens laid out. All the level icons are manually laid out, and it has a camera here in the middle that is being tracked. And you'll notice how the menu system appears to be multiple pages just by tracking this scene object and animating the scene object with some different rules to handle dragging and limiting the position of how far the object can go. So just to give you an idea of what this looks like. Now you'll notice if I drag to the right, it's limiting how much drag is allowed, and it snaps back and animates back into position. So there's rules that are handling all of this behavior, but ultimately the root of this technique, or the root of this example, is just using the scene tracking with some rules. So the minute this guy crosses a certain threshold or position on the screen, the page changes, and the exposition of where the scene should snap back to changes as well. So it looks like there's a change in the screen. And also there's logic here to animate into different positions by toggling these UI elements at the top here as well. What you'll notice is as I'm clicking around in the scene and then dragging, this little object up here keeps moving and snapping to where my mouse goes. So what's happening is this object is used to determine the velocity that the scene should move in. So as I click down on the scene, we snap this object to where the mouse down happens. So we're capturing the position of where the mouse down or where the touch happens. And let me go to the logic here. So on mouse down, we use a change a change property action to snap the X position, because we're only worried about the horizontal position. We're not doing any vertical movement. So we set the position of this object to where the mouse actually touched down along the x-axis. We snap it there, and then what we do is we use a constrain property action, which triggers every frame, so it's a constant trigger. And what we do is we calculate the difference of movement. So from the position, or whatever the current x position of this object is, as we're moving our mouse, this game.mouse.x value continues to change. So we calculate what is the difference between where the object currently is and where the mouse is now located, and it determines a value, or the difference, the amount of difference there between those two values, or those two positions. And that will give you a certain strength or velocity to move your object. And we have a multiplier here that just magnifies the velocity to a certain level. And this could be whatever you want. And this will determine how fast or how slow the this little tracking object will catch up to the mouse movement. And this will determine how fast the dragging happens. So this calculation is constantly applied to the linear velocity of this object spatial. So it's a smooth movement, and to achieve smooth movement in GameBuilder Studio, you set a velocity on an object, and it'll constantly move in that direction. And that's what we want to simulate that drag. And what happens is this object's linear velocity gets applied to this camera object here. And that's how we get the smooth movement of the scene, moving from left to right depending on where you're dragging the mouse. Now, I showed you at the beginning how track by offset and track without the offset works. So if we're look at this example again, as I put my mouse down, the little gray drag indicator pops into position, and as I move, the scene moves with this object. Now, in order for this to work correctly, to where we have the menu moving in the direction that the mouse is moving, we have to actually flip the velocity that's coming from this object when we apply it to the camera, because whatever direction the camera moves in, the scene moves in the opposite direction when using track by offset, which is what we're using on this object. So if I go to camera tracking, you'll see here that I'm using tracking here by offset. I'm hiding the object when it loads. And I'm flipping the linear velocity by adding a negative sign to the x property of the velocity from the dragger object. So I'm referencing the dragger entity, which is this object, and I'm flipping its velocity. So I'm giving it the inverse of that. And this is using a constrained property, so it's continuously applied. And there's a couple properties on this camera tracker object. The snap to X position, so that gets updated depending on what page is in view. When this object collides with the there's an object here that is tracking when a collision happens with this page area indicator, and it changes the value, or the current page value. So the current page number and the snap to X position. And these values are going to be used to determine when the mouse is released, where does the scene need to animate to or snap to put the menu into position. And then you have properties here to determine how much to allow the menu to move. So if the position of this camera object is less than a certain amount, it'll stop um, the velocity that's being applied. So it starts to reduce the velocity. It adds or it starts multiplying it by a value which continuously reduces the linear velocity. And here you'll see once the mouse is released, we actually snap it into position by using that snap to X position using an interpolate action, and we stop the velocity of the dragger so that it'll animate into position and it'll stop movement. So that's pretty much how this level select menu works. Tracking objects has no limit, so you could drag this object all over the scene, and there wouldn't be any cap of where the tracking would stop. There is a way to limit the amount of tracking to a certain region. So what I'm going to do is visually show you how to do that using a simple square object as the indicator for the region. Now you could just manually plug in the values, but it's easier to see where the region is by in the scene by actually using one of these objects. I don't need to dissimulate with the scene, so let me convert it spatial to just use a basic spatial. Get rid of the old one. And I want the registration point to be in the top left corner. And I want to be careful not to scale this guy. I want to actually change the size of it. Say to maybe make it maybe even reduce it more than that. So the camera will only, or the scene will only track within this region. And I will add logic to this. I'm going to hide it on load because I'm just using it in the scene as a representation. And I'm going to put it all the way at the bottom. Now there is a property on every scene object. So for every renderer in the scene, there is a property called scene. Every render has this. Now there is a property on scene called limit. Rather, it's called track limit rectangle. And I'm going to use an expression because there's a new helper method called set rectangle, which takes an x and y coordinate, which will be the top left of this object, and the width and height. So I'm going to find that entity, and I want to access it. It's spatial. I want its x and y values, and I want the size. Dot x is the width, and size dot y is the height. Now, if I had scaled this object, I would have to actually multiply the size times the scale of the render on this entity. That's why I made sure to change the actual size property. Now, if I move this object, it only moves within within that region. It caps it. So that's a way to limit the amount of tracking that's allowed by setting a specific region, um, using an object as a reference, or you could just plug in the numbers directly.